These are the lesson activities for College Algebra Lesson 23. I want to divide -6 plus 5x plus 6x squared by 3 plus 2x. So first, we write things in descending powers of x. So I have 6x squared plus 5x minus 6, and I'm going to divide by 2x plus 3. And then you look at your leading terms and you say, what do I multiply 2x by to make 6x squared? And the answer is 3x. So now I'm going to multiply 3x times 2x plus 3. 3x times 2x is 6x squared. Okay. And 3x times 3 is 9x, and then I subtract. So the 6x squareds go away. 5x minus 9x is negative 4x. Bring down the negative 6. And then you start again. You look at the 2x, the leading term, look at the leading term over here, and you say 2x times what would give you negative 4x? And the answer is negative 2. Negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6, and we subtract. Negative 4x minus negative 4x is 0. Negative 6 minus negative 6 is 0, so I have a remainder of 0. And we want to check the answer by multiplying our divisor by our quotient, see if we get our dividend. So 2x plus 3, this is our check, times 3x plus 2. We'll do firsts, I get 6x squared. Outers plus 4x. Inner is plus 9x. And lasts plus 6. And that's not right, because 4x and 9x is 13x, not 5x that I was looking for. And you see what happened is I got 3x minus 2 as my quotient, and I wrote it wrong down here. This should be 3x minus 2. And let's check that again. Okay, so 2x times 3x is 6x squared. 2x times negative 2 is negative 4x. 3 times 3x is 9x. And 3 times negative 2 is minus 6. And now when I combine like terms, I get the plus 5x. I have 6x squared plus 5x minus 6. Checks out. Okay, so looking at the graph of -6 plus 5x plus 6x squared, I want to verify my answer using this graph. So I know I should have zeros. To find zeros, I'm going to set my function 2x plus 3 times 3x minus 2 equal to 0. So then I set each factor to 0 separately. So I get x is negative 3 halves. And then 3x minus 2 equals 0, and I get x equals 2/3. Does that look about right? That looks like it's at about 2/3, and this 0 looks like it's at about -1.5, so that checks out. Okay, another example. This time I'm going to divide x cubed minus 2x squared minus 5x plus 6 by x minus 3. So I asked myself, what do I multiply x by to make x cubed? And the answer is x squared. And then x squared times x is x cubed. X squared times negative 3 is negative 3x squared, and I subtract. So x cubed minus x cubed is 0. Negative 2x squared minus negative 3x squared. So negative 2x squared plus 3x squared is x squared, and then I'm going to bring down the minus 5x plus 6, and then I start again. I say x times what would give me x squared, and the answer is x, and then multiply x times x minus 3. So x times x is x squared. X times negative 3 is negative 3x, and I subtract. X squared minus x squared is 0. negative 5x minus negative 3x. Look, I've got a minus, a negative, which is really a plus. So negative 5x plus 3x is negative 2x. Bring down the plus 6. And then I start again. I ask myself, what do I multiply x by to make negative 2x? And the answer is negative 2. And then I multiply that negative 2 times my x minus 3. So negative 2 times x gives me negative 2x. Negative 2 times negative 3 gives me positive 6, and I subtract, and my remainder is 0. So that means that I have rewritten the original cubic function as a product of the divisor and the quotient. So I can say that x cubed minus 2x squared minus 5x plus 6 should equal x minus 3, the divisor, times the quotient. Okay, this is my check. I'm going to multiply these together and make sure that I get the original dividend. So I can't use FOIL here because FOIL only works if you have a binomial times a binomial, 2 terms times 2 terms. But I can still distribute. I'm going to distribute the x to every term. I'll do that in purple. So x times every term in the second parentheses. So x times x squared is x cubed. X times x is x squared. And x times negative 2 is negative 2x. And then I am going to distribute the negative 3 to every term in the parentheses. And so I have negative 3 times x squared is negative 3x squared. And negative 3 times x is negative 3x. And negative 3 times negative 2 is plus 6. And then combine like terms. And I have x cubed minus 2x squared minus 5x plus 6, which is exactly the function I started with. Checks out. So before using long division, we have seen that you should write the divisor and dividend in descending powers of x. If a power of x is missing, you should insert the missing power of x with a 0 coefficient and then carry on with the long division. This is exactly what we do with numbers when we divide numbers. We use a 0 to indicate that we have no ones or no tens or no hundreds. We put a 0 as a placeholder. And it allows us to line up like terms when we're doing our long division. So let's do an example where we have to do this. If I want to divide x cubed plus 1 by x plus 1, first we rewrite x cubed plus 1 as a polynomial in descending powers of x, and I'm going to add in a 0x squared term and a 0x term. So I've got a cube term and I've got a constant term, and I'm missing an x squared term and an x term, so I'm going to add them in, but put 0 coefficient in front of it, and then do the division. So I'm going to do x cubed plus 0x squared plus 0x plus 1 and divide that by x plus 1. So we start by asking ourselves, what do you multiply x by to make x cubed? And the answer is x squared. Then you multiply that x squared times the x plus 1. So x squared times x is x cubed. X squared times 1 is x squared, and we subtract. The x cubes cancel. 0x squared minus x squared is negative x squared. Bring down the 0x. And we say, what do you multiply x by to make negative x squared? The answer is negative x. Negative x times x is negative x squared. Negative x times 1 is negative x, and we subtract. Negative x squared minus negative x squared is 0, because the minus a negative becomes a positive. And then 0x minus negative x. So that's 0x minus negative x. Minus a negative is really a plus. So 0x plus x is x. And then I'm going to bring down the plus 1 from way up here. Just drop that down. And then what do you multiply x by to make x? 1. 1 times x is x. 1 times 1 is 1. We subtract, and we get a remainder of 0. So I want to use multiplication to check my answer. So I'm going to check that when I multiply my divisor by my quotient, I get my original dividend. So I'm going to do that over here because I kind of stole the room for part B. So I'm going to do x plus 1 times x squared minus x plus 1. So I multiply the x in my first parentheses by every term in the second parentheses. So x times x squared is x cubed, x times negative x is negative x squared, and x times 1 is x. And then I'm going to multiply my 1 in the first set of parentheses by every term in the second set of parentheses. So 1 times x squared is x squared, 1 times negative x is negative x, and 1 times 1 is 1. And then we just combine like terms. So I have x cubed, and then I have a negative x squared and a positive x squared. That makes 0 x squareds. I have a positive x and a negative x, that makes 0 x's, and then I just have a plus 1, which was my original dividend. Number 4, use the factor theorem to solve the equation 2x cubed minus 3x squared minus 11x plus 6 equals 0, given that we already know that x equals negative 2 is a 0. So I already know one solution to this equation. Negative 2 is one solution. Okay, so x equals negative 2 is a 0. That means that by the factor theorem, f of negative 2 equals 0. That's what a 0 is. And that means that x plus 2 is a factor. That's what the factor theorem says. If you know a 0, if you know the 0 is negative 2, then you have a factor of x plus 2. And then I can use long division to find the other factors. So I'm going to do x plus 2 divided into 2x cubed minus 3x squared minus 11x plus 6. And x times what gives you 2x squared, or 2x cubed? That would be 2x squared. 2x squared times x is 2x cubed. 2x squared times 2 is 4x squared, and we subtract. The 2x cubes cancel. Negative 3x squared minus 4x squared is negative 7x squared. Bring down the minus 11x. X times what gives you negative 7x squared? That would be negative 7x. Negative 7x times x is negative 7x squared. Negative 7x times 2 is negative 14x. We subtract. The negative 7x squareds combine to make 0. Then I have negative 11x minus negative 14x. That's plus 14x. So negative 11 plus 14 is 3x. Bring down the plus 6. And then we have x times what gives me 3x. And the answer is 3. And then multiply the 3 times the x plus 2. So 3 times x is 3x. 3 times 2 is 6, subtract, and I get a remainder of 0. So I can rewrite my original function f of x as a product of my divisor times my quotient and what I'm trying to do is solve for when this equals 0. So I'm going to set this equal to 0 because that's what I was originally trying to solve. When does my function equal 0? So I can set each factor equal to 0 separately. So I have x plus 2 equals 0, which gives me x equals negative 2. I already knew that was a 0, right? They gave me that early on. But now I have another factor, 2x squared minus 7x plus 3 equals 0. And I can either try to factor that or use the quadratic formula to finish solving. I believe this is going to factor to 2x and x. And I need a negative 7x. So maybe minus 3 minus 1, because that would give me the 2x squared, negative 6x minus x plus 3. Yep, that works. Then set each of those factors equal to 0. 2x minus 1 equals 0, which gives me x equals a half. Or x minus 3 equals 0, which gives me x equals 3. So I've now found the other two solutions to that equation. So if they give me 1, I was able to find the other two by doing long division to get another factor, and then setting that factor equal to 0 and solving. Number 5, use the factor theorem to decide whether or not x minus 2 is a factor of p of x equals x cubed plus 2x squared minus x minus 10. So the long way to answer this question would be long division. You're going to take your p of x, divide by your x minus 2, looking to see if you have a remainder of 0. If you get a remainder of 0, then x minus 2 is, in fact, a factor. But the factor theorem is going to make this a lot quicker. It says, remember, if x minus 2 is a factor, okay, that means that 2 is a 0. And so now I just want to check to see if it's a 0. I want to show whether or not p of 2 equals 0. So p of 2 would be 2 cubed plus 2 times 2 squared minus 2 minus 10. So that comes out to 8 plus 2 squared is 4 times 2 is 8 minus 2 minus 10. So 16 minus 2 is 14. 14 minus 10 is 4. That is not 0. So x minus 2 is not a factor. Number 6, write an equation of the lowest possible degree for the polynomial pictured. So the zeros of the polynomial looks like they happen at -2, 0, and 1. So I have x equals -2, 0, and 1, which means that my function has factors x plus 2, x minus 0, and x minus 1. And then I'm going to put some exponents on this to account for the multiplicities. On the 1, I have a bounce off, which means I have even multiplicity. So the lowest power of x I could put on that is a 2. I need an even power. Smallest even number would be 2. Okay, at x equals 0, this goes straight through the x-axis. And if you were to zoom in on that, it would look like a line, which means I think that would have to be the first power to look like a line. And then at -2, it goes through the axis, but if you were to zoom in on the -2, it kind of looks like an x cubed because it flattens out as it goes through. So that means that it's going to be odd because it goes through the x-axis, but it's going to be higher than 1. So I'm going to give it a 3. And then it says use the point -1, -2, -1, -2, this point that's on the graph right here, to determine the value of the leading coefficient a. So this is an x coordinate, this is a y coordinate. So I'm going to make all my x's -1s, make my y -2, solve for the a. So I have -2 equals a times -1 plus 2 cubed times -1 minus 0 to the first times -1 minus 1 squared. So -2 equals a times -1 plus 2 is 1, cubed is 1. -1 minus 0 is -1 to the first, which is -1. And -1 minus 1 is -2, which when we square, we get 4. So -2 equals -4a. So a is 1/2. And then my final answer is going to be this function, but replace the a with a 1/2. So I'm going to have 1/2 times x plus 2 cubed times x minus 1 squared. Number 7, write the following polynomial function in completely factored form. So I have a cubic, x cubed plus x squared minus 10x plus 8. Use the graph of f to find all x-intercepts or zeros, and then write the function in completely factored form. Then check that the zeros you find are correct. Okay, so it looks like -4, 1, and 2. I've got 3 nice zeros, and there should be exactly 3 zeros for a cubic function. So let's see, x cubed plus x squared minus 10x plus 8. The leading coefficient is 1. The degree of the polynomial is 3. The number of x-intercepts is 3. And the zeros are -4, 1, and 2. So to write this in completely factored form, I would have f of x equals a, the leading coefficient, which we had as a 1, x plus 4, x minus 1, x minus 2. How many linear factors is that? 1, 2, 3. Same number of factors as there are zeros as the degree. So check each zero of the polynomial. So f of -4, that would be -4 cubed plus -4 squared minus 10 times -4 plus 8. Does that equal 0? It should. -4 cubed is -64 plus 16 plus 40 plus 8. That is, in fact, 0. And then I'm going to check f of 1. So that would be 1 cubed plus 1 squared minus 10 times 1 plus 8. So 1 plus 1 is 2, minus 10 is -8, plus 8 is 0. And then f of 2, that would be 2 cubed plus 2 squared minus 10 times 2 plus 8. That's 8 plus 4 minus 20 plus 8. So that's 12 minus 20, which is -8, plus 8 is 0. Okay, lastly, we want to multiply our factored form to check that it equals x cubed plus x squared minus 10x plus 8. So I want to multiply x plus 4 times x minus 1 times x minus 2. So I'm going to start with the second two factors. I'm going to FOIL them. So I'm just going to copy the x plus 4 for now. And I'm going to FOIL x minus 1 times x minus 2, and I get x squared minus 3x plus 2. And then I'm going to distribute the x from my x plus 4 to every term in my second set of parentheses. So x times x squared is x cubed. X times -3x is -3x squared. X times 2 is 2x. Now I'm going to multiply my 4 from the first set of parentheses to every term in the second set. So 4 times x squared is plus 4x squared. 4 times -3x is -12x. And 4 times 2 is 8. Okay, when I combine like terms, I get x cubed. And let's see, my like terms, I have -3x squared plus 4x squared, which is plus x squared. And then for x terms, I have plus 2x minus 12x, which is plus minus 10x. And then a plus 8, which is exactly what I was hoping to get.